Well, let's take a look at the beginning of this next unit. So this is Unit 2 and this is Section 2.1. And what we're going to be talking about today is we're going to be learning about how to combine like terms. So we'll write the word like here. And we're going to talk about what like terms are and learn how to combine them. So as a warm-up today, here's what we're going to do. We're going to take a look at a couple of problems, one with fractions and one with decimals. And you should be able to do these without a calculator. So this is just a good review. We're going to spend more time a little later in the course talking about numbers like this and how we can deal with these. But for right now, we've got 1 7/9 minus 5/9. Now there are a couple different ways to deal with this. You'll notice that we've got 1 7/9 minus 5/9. We've got a couple good things going on here. First of all, we already have a common denominator. And the second one is we're taking away 5/9 from the 7/9 right here. And we've got this whole number here. So what we can do is we can say, well, the answer is going to be 1, and then if I take 7/9 and I subtract 5/9, we end up with 2/9, and that would be the answer on this one. We could also, and this happens a lot with fractions, we have to deal with them and we put them in what we call improper form. So I could take this and we could do 9 times 1, that would be 9, add the 7, that would be 16/9 minus 5/9, and we end up with, let's see, 16/9. Again, we've got that common denominator. 16/9 minus 5/9, we end up with 11/9. Now I've got two different answers on this one. We've got 1 2/9 and we've got 11/9. And if we take a look at this one right here, this is what we call a mixed number, and this is what we call a fraction or an improper fraction because the numerator is bigger than the denominator. In a case like this, this is the type of answer you would have focused on in elementary school, writing things as mixed numbers. Once we get to 7th grade and beyond, once we get to things like algebra and pre-algebra and that sort of thing, we really like improper fractions, and there's a good reason for that. We always want to reduce fractions, but we want to leave them as fractions even if they're improper. So this is probably the better way to write the answer. I'm going to put a little star by that one right here. Let's take a look at this decimal problem. We've got negative 2.7 minus 0.4. So I'm sure you've seen decimal problems before. So one question might be, well, these are both negative. How do we deal with that? Well, it turns out the rules for dealing with this are just like dealing with integers. So these have the same sign. So we're going to find the sum of those numbers. So we're going to do 2.7 plus 0.4. So that would be 11. Carry the 1, so that's going to be 3.1. So the answer is 3.1, but remember, same sign, we find the sum of the numbers and then we keep the same sign for the answer. So the answer there would be negative 3.1. Alright, so these are a type of mathematical expression, and we run into mathematical expressions all the time. These happen to be very simple ones that you're already familiar with. And then just a quick reminder, as we start learning algebra and that sort of thing, a mathematical expression is a group of numbers, variables, and if you don't know what a variable is, we're going to talk about those in just a second, and operations. And we've talked about operations before. We'll run through those again as well. So a mathematical expression is a group of numbers, variables, and operations that show the value of something. And we'll deal with a lot of different expressions, and you'll get used to the way they work and that sort of thing. So let's talk about variables for just a second. A variable is a symbol, usually a letter. They're just really convenient symbols that are used to represent a number. And sometimes people say they're used to represent an unknown number. That's totally okay if you want to think of it that way. The nice thing about what variables do for us is they allow us to represent many situations with one expression. And what this does is it saves us a lot of time and a lot of effort in the long run. All right, let's talk about operations. Operations, again, that's what we typically think of when people say, hey, we're going to do the math. There are those 4 basic operations. So we've got add, we've got subtract, we've got multiply, and we've got divide, division. Okay, so when we add, subtract, multiply, or divide, those are the 4 main operations that we deal with in math. Now, there are times where we're going to get something that looks really awful, some mathematical expression that looks like this. You'll notice that we've got some variables in here. We've got an x here and an x there and an x there. We've got some positive numbers, some negative numbers. And what we need to do is we need to clean something like this up. And when we clean up a mathematical expression like this, what we call that is we call that simplifying. Simplifying. Mathematicians like to write things as simply as possible and as accurately as possible. And one of the most common ways that we're going to simplify expressions is we're going to combine like terms. So that's what this section is all about. It's about combining like terms. So let's talk about what a term is. Terms are the individual parts of an algebraic expression that are separated by a plus or a minus sign. So if they've got a positive or negative sign separating the terms, that's what's going to separate them. So for example, if I've got a 5x, that's a term. Negative 3gh, that's a term. Plain old x, that's a term. If we've just got a plain old variable, or like on the end here, a plain old number, or maybe we've got several variables here and then one number, those are all terms. The number in front of the variable is called, it's got a special name, it's called a coefficient. Coefficient, okay? So the variable term 5x has a coefficient of, now this is the variable, x is the variable, and the number in front is the coefficient. So the coefficient is just the number 5. 5x is the whole term, and 5 is the number in front, so that's the coefficient. So the variable term negative 3gh has a coefficient. Again, it's just the number out in front, so that would be negative 3. Now we've got this variable term right here, it's just a plain old x. Now if it is a plain old x, what's understood to be in front is a 1. So the coefficient there, whether you recognize it or not, is just a 1, and that might be something that you need to get used to. So if we had something like this, if I had b, the coefficient in front is 1. If I had negative y, the coefficient in front would be negative 1. So this is understood to be a 1b, and this is understood to be a negative 1y. So those would be the coefficients there. Again, mathematicians like to make things as short and as quick as possible, but still be very accurate about it. So rather than having to write the 1 all the time or the negative 1, if there's not a number written in front of a variable, we assume that the coefficient is a 1. So we've got another variable term here, negative 2abc. That has a coefficient of negative 2. And then if we have a term that's just a plain old number like negative 7, you'll notice that every single one of these has a variable in it. It has a letter, and that letter could represent lots of different numbers. So we wouldn't be able to say what number the entire expression represents because we've got implied multiplication here and here, 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 and here. So what we call this, because this is not going to change, it's not going to vary at all, we call that a constant. Okay? So we've got one C word, coefficient, that's the number in front of the variable, and then we've got another C word, that's a constant. That's a plain old number, doesn't have a variable attached to it. Okay? So let's talk about what like terms are and how we can tell whether or not we've got like terms. Like terms are terms that have the same, I'm going to say same variables. In fact, I'm going to write variable, and then in parentheses I'm going to put an S. If it's got more than one variable, it's got to have the same variables and the same exponents. Okay, and I'm going to put the S in parentheses there as well. Now, we're not going to deal with a ton of exponents, but we will deal with a few. And hopefully you've heard of exponents before. If not, we can spend some time going over that and making sure everybody's on the same page and that sort of thing. But let's take a look at these first problems right here. And as we go through these, I want you to keep the vocabulary in mind. So we've got coefficients, that's the number in front of the variable. A constant is a plain old number. Terms are separated by plus and minus signs, and if we have like terms, they have to have the same variable or variables and the same exponent or exponents. So let's run through here and let's take a look at the instructions. The instructions on this one say identify the terms of the expression and state the coefficients of each, or state that it is constant. Okay, so let's identify the terms first of all. So I want you to look at this and figure out how many terms that has. Remember, plus and minus signs, the operation of adding and subtracting, separate terms. So we've got a term right here, we've got a term right here, and then we've got a term right here. So we actually have 3 terms. So we've identified the terms and then state the coefficient of each or state that it's a constant. So on this one right here, we've got the term 4x. So 4x is a term, 3 is a term, and negative 7y is a term. So this is what the term is, and then the coefficient, I'm going to abbreviate that, coef there, make that look a little bit better. Okay, so the coefficient here is a 4. The coefficient, let's see, is that a coefficient? That's not a coefficient, that's a constant. Okay, we'll take care of that in just a second. And then we've got negative 7 here for the coefficient. And then the constant, the only one that's a constant is this one right here. So we've got a constant of 3, we've got a variable term of 4x, a variable term of negative 7y. So the coefficient here is 4, coefficient here is negative 7, and that 3 is just a plain old constant. You will notice that this isn't written in the correct order, and we'll take care of that if we have to do some simplifying here in just a second, but we're working on identifying terms right now. So let's see, the term right here is 4x. We've got another one that's very much like that, okay, and then we've got two constants here, okay. So each one of these is a term. I'm going to just go off to the side here, and I'm going to write that the coefficient is 4. The coefficient right here is negative 3, and each one of these is a constant. So I'm going to write const is 6, and the constant here is 5. Okay, so all we're doing here is just kind of getting used to the terminology, recognizing terms, and that sort of thing. So now we actually want to go through and we want to do some examples where we actually simplify the expressions by combining the like terms. And one thing I want you to keep track of here, and I know this has asterisks by it, but if you would put some on there when we write this in here, make sure that you get this memorized. We normally write expressions in alphabetical order. So if we take a look at this right here, we've got 4x plus 3 minus 7y. In order for them to be like terms, they have to have the same variable and the same exponent. There aren't any exponents on this one right here, so we're just looking for terms with the same variable. Like we had up above, there's only one x term, there's only one constant term, and there's only one y term. So the only thing that we're going to do to simplify this is we're just going to write it in alphabetical order. So x comes before y, so we're going to write down 4x. We've got now got the y term, so negative 7y, and we're going to put the constant on the end. Okay, so we'll go ahead and circle that. That's simplified. We're done. Now, if we take a look at this example right here, again, these are copies of the ones up above, and then we've got this extra one right here. Let's take a look through here. We've got two terms that have x's, okay? And then these other ones, these are just constants. Now, the constants are going to go at the end, the variables are going to go at the beginning. So what we're going to do here is we've got 4x minus 3x. Let's see, 4x minus 3x, that would be 1x. It's just like the rules for combining integers. They have different signs, so we'll find the difference. The difference is 1. X, the bigger one is 4, so it's going to be positive. Again, sometimes you could substitute words like you could say 4 apples minus 3 apples would give us 1 apple. So we've just got 1x. And again, we could write this, or I'm going to show you a different way to write it in just a second. So we've got that one taken care of. I'm going to go ahead and cross those off just lightly. And then we're going to do the 6 and the 5. Those are constants. Positive 6 and positive 5, that would make positive 11. So I could write it this way, but we normally don't write that 1 in front there. So probably the best way to write this one would be x plus 11, and that's what I'm going to circle there. Okay, and then let's take a look through here. We've got a y term and a z and another z and an x and a 4, or sorry, a y term and then a plain old 10, a constant at the end. So if we're going to put these in alphabetical order, this is the first one we're going to write down. So we're going to write negative x. So that just means negative 1x, and I'm going to lightly cross that off. Don't scribble it out so you can still see it. Then let's take a look through here. I've got a y term right here, and I've got another y term right here. So if I have 9y plus 4y, they have the same sign, so I'm going to find the sum. That's going to be 13, and since they're both positive, the answer is going to be positive. Again, I'm going to lightly cross that off so I know I'm done with it. Then we've got these z terms right here, so I'm going to put a little squiggle underneath each one of those. Negative 7z plus 4z, again, because they're like terms, this is now just using those same rules for integers that we did before. Different signs, we're going to find the difference. The difference is 3, the bigger one's negative, so this is going to be negative 3z. Again, we'll lightly cross that off. So you'll notice that we've taken care of all of these, and the only thing left is the constant, and we're going to put that at the very end. So we've got this in alphabetical order with the constant at the end, and there's our answer. Now, just as a reminder, the rule here for like terms is they've got to have the same variables and the same exponents. But you'll notice that we've got these constants here that we went ahead and combined. They don't have a variable at all. So all constants are like terms. They don't have any variables. So you can kind of say, well, if they don't have any variables, then they've got to be the same. So all constants are like terms, so they need to be combined. So don't forget that. All right. So let's flip the page over and let's do a couple more problems, and then we'll give you some time to work on your assignment and kind of practice these skills before we make things just a little bit more complicated. Okay, let's take a look at this one. Let's run through and take a look. We've got 1, 2, 3, 4, 5, 6 different terms. You'll notice that we've got some G's and some H's and some plain old constants here. So alphabetically, let's do the G's first. So there are the terms with G's in them. 7G minus 9G. 7 goats minus 9 goats would be minus 2 goats. So we've got a G on there. Okay, we'll lightly cross that off. Let's do the H's next. 2H plus 3H. 2 helicopters plus 3 helicopters would be 5 helicopters, or 5H. We'll cross those off. And again, those are both constants, so those are like terms. They're just integers, so we'll combine those and we'll get -1. So you'll notice what we have here is we've got a simplified expression, much shorter and simpler than what we had before. We've got it in alphabetical order with the constant at the end. Now, this one's a little bit unique because we've got more than one variable on each one of them. So remember the rules. They've got to have the same variable or variables. And let's see here. So we've got an XY term. We've got another XY right here. So I'm going to underline those with kind of a looping little curve. I've got a YZ. Okay, so I'm going to say those are both the same. And then we've got this 9Z sitting on the end there. That really doesn't have anything in common with the other ones. So they have to have the same variables. So these two are like terms. The XY term here and the XY term here, those are like terms. So if I have minus 2XY minus another 4XY, that's going to be -6XY. Again, same sign, find the sum, keep the same sign, lightly cross that off. Let's look at the YZs. This is 3YZ minus, remember this is an understood 1YZ. I'm going to write that in there for the time being, and then we'll eventually kind of get away from that. So 3YZs minus 1YZ, that would leave me with 2YZ. Lightly cross that off, and then we've got that Z at the very end, that 9Z. Now, there's no real hard and fast rule for writing these. I kind of like this a little bit better than one other way that we could write this. So because there's so many variables floating around here, it's not a huge deal which order they're written in, but you'll notice I've got X's and Y's, then Y's and Z's, and then Z at the very end. That kind of makes sense alphabetically if you wanted to, and I wouldn't recommend this. I kind of like this a little bit better. You could do this. We could write the 9Z first, just kind of going, well, it's only got one variable, and then we could do the -6XY and then the +2YZ. That would be okay, but I really like that first way of writing the answers a little bit better. So if you run into anything like that, really prefer you write the variable. If they've got more than one variable, write those first, write those in alphabetical order, and then write the other ones in alphabetical order as they come after that. And remember, the constant always goes on the end. All right, good luck with that first assignment. Thanks.